Okay, in this video we're going to take a look at right-hand and left-handed limits. So let's go ahead and start. The learning goal. Students will be able to know what a right-hand limit and a left-hand limit basically is, and also know if the general limit exists. So by the time we finish this video, you're going to hopefully know what a right-handed limit looks like and a left-handed limit looks like, and you're going to basically be able to see if the general limit exists. So let's go ahead and scroll down here. Just a little bit of review. The most important part: what is a limit? A common sense definition, once again, it's just a limit is the intended height of the function. I love this. I never knew this when I took Calculus 1. It took me a while till I was in, I think, Calculus 3 to really understand what a limit was. Very simple, very basic, just the intended height of the function. Okay, let's go ahead and let's take a look at limit notation here. So if I have a right-handed limit, it basically looks like this. The limit as x approaches 2, and then it has a little plus here for right-hand side of f of x, and in this case I just said equal to 4. You would have to solve and see what it's equal to. And then on the left, for a left-handed limit, basically it's the same thing, limit as x approaches 2, and then we say, because it has a little negative there, it's the left-hand side of f of x is equal to 4. So the way you would read it to someone is the limit as x approaches 2 from the left of f of x. And then the way you would read the right-handed limit, once again, is the limit as x approaches 2 from the right of f of x. Now this is very important. If they ever ask you, does the general limit exist, you need to show that the left hand and the right hand limit are both equal to the same number. Now we've been working with general limits already. The general limit won't have a little plus or minus. It just would be the limit as x approaches 2 of f of x. So once again, very important, if we show that the right side and the left side have the same height, then the general limit exists, and it's at that same height. So that's how you would prove it. Now let's talk a little bit about how we approach from the left and the right. So when does the limit exist? The general limit only, remember, when the left hand and the right hand side have the same height. So what I mean by that is this: if you wanted to write a basic general limit, you would first, if they ask you if it exists, you'd first need to show that the limit as x approaches, in this case let's say 0 from the left of f of x, and we'll name it f of x. What the heck? Okay, so to approach from the left, that means I'm going this way. So this is my left hand side, and I'm getting closer and closer and closer to 0. Now let's say that that height was 7. And then if I want to approach from the right hand side, let me grab another color here, Mr. Green, I would write the limit this way: the limit as x approaches 0 from the right hand side of f of x, and that's a right-handed limit, and I would approach from the right. And if that is equal to 7, then we would know that the general limit, limit as x approaches 0 of f of x, would also equal 7, and it would exist. Very nice, very easy, but a lot of people forget to show the left, the right, and then bam, therefore the general limit exists. So remember, if the height from the right and the left are the same, then the general limit exists. Okay, so let's go ahead and go to our first example here. Alright, it says find the left and right-handed limits and state if the general limit exists. Okay, and they even give us where we want the location on the x-axis. So it says where x approaches 4. Okay, let's begin. Let me grab Mr. Blue, and I'll work up here. So to write the left-handed limit, I would write limit as x approaches 4 from the left. Now notice they don't give us the actual name of the function. They just call it g of x. Not a problem. Okay, so let's see if we can figure out what the height is, or the intended height from the left. So let me grab a highlighter here. If I'm approaching from the left, I'm on the left-hand side graph, and I would just go all the way up till I got this height right here. And it looks to me like the height is 1. So let me go ahead and put down 1. I'll even label this for you. 1, 2, 3. Okay, so now let's go ahead and let's take a look at the right-handed limit. So let me grab a red pen. The limit as x approaches 4 from the right of g of x is equal to. Okay, so let me grab my highlighter here. And I'm going to go from the right all the way down. Now I don't want you to be worried about this hole. Limits, remember, it's the intended height of the function. And here, down here, you have 4. That's what we're approaching from the left, which we just did, and from the right, which we're doing now. And even though we never reach this whole location, we're so close to 4 that we can find a height. It's the intended height. So it looks like the height there is going to be 2. Now what we can say is, let me grab Mr. Green, therefore the general limit as x approaches 4 of g of x, does not exist. And the reason why it doesn't exist is from the left the height is 1, from the right the height is 2, so therefore the general limit doesn't exist. This doesn't mean that the left-handed limit nor the right-handed limit doesn't exist. It just means that the general limit. Okay, so I hope that made sense. These are kind of fun. These are my favorite. Let's go ahead and let's scroll down and we'll take a look at our last example. It says show that the limit does not exist. Okay, so I want to show that the right hand side is equal to something, the left hand side is equal to something, and then I want to show that the general limit, if it doesn't exist, that means the right and the left are both different. So first thing I want to do is I want to graph, and before I graph I want to take our function f of x is equal to absolute value of x over x, and I want to try to create a piecewise function out of it. I can't graph it this way, it's too complicated. So the way I would do that is this: f of x is equal to, and then got a little excited, wrote 2 equal to, so let me erase that part. And then what I would do is I would have to split it into 2 pieces. A positive piece and a negative piece to get rid of that absolute value. So when I do that, I would get positive x over x, which is just going to generate positive 1. And then here I would say negative x over x, which is just going to generate negative 1, because of course you just cancel those out. Now where x is and x is doing something. Now because I'm going from the right, let me grab another color here. Because I'm going from the right, and I know it's the right because it's positive, I would write greater than, because I'm approaching from the right. And here, you guessed it, I'm approaching from the left because it's a negative. And we're approaching 0 on both of these. Okay, so this is my piecewise function. I'll even rewrite it for you. F of x is equal to, in this case, 1 where x is greater than 0, and negative 1 where x is less than 0. Remember that we have a positive, so it's going to be right hand side, and we have a negative, which is the left hand side. So now let's go ahead and give it a face. Let's sketch this thing. Okay, much simpler when they give you a graph, I know. Okay, so this right here, my friends, is f of x equals 1. That's a horizontal line, and basically it would look a little something like this. So we would go up to 1 and we would draw a straight line, and at 0 I have a hole because it's not equal to. Okay, let's take a look at the next one. Negative 1. Okay, If you're like, well, why did you just draw the right hand side? Well, basically it said x is greater than 0, so all the numbers greater than 0 on the x-axis are on this right side here. Okay, so the next one, -1, still f of x equals -1, a horizontal asymptote. And instead of looking at the right side, I'm going to look at the left. So it's going to be basically like this. Okay, already we can see that our general limit doesn't exist on 0 or at x equals 0. So let's see why. If I'm approaching from the right, I'm going this way, and I'm going all the way till I hit 0. It looks like my height is 1. If I'm approaching from the left, it looks like my height will be -1. So therefore, that's what these little 3 dots mean, the general limit does not exist because the height from the right and the left are not the same. Okay, so let me scroll up again. It says for our learning goal, let's see if we met it. Students will be able to know what a right-handed and a left-handed limit are. I believe you do, especially the notation, and if the general limit exists. I think we did a good job. If you still aren't grasping it, I'd say watch the video one more time. I'll see you on the next video.